Alright guys, so here's the recent changes I've done to the design of the submarine. I haven't worked on this in a while, but I'm finally picking it back up because I want to get this done and work on something else. So here are some of the changes that I did to the parts of the submarine. The first thing I changed was the way I was going to attach everything. So now the way I'm attaching it is that this cap goes on the top of this, and these squares right here, they go into these parts right here. And then as you guys can see, there's holes on the outside of the submarine itself, and you just screw it in and it should lock in place. And another thing I changed is the way that the rudders work. So before, the way I had it was it would be in a completely different area in the submarine, and it would control the fins by using metal wire and attaching the servo horn onto the rod that will connect. It would connect two different fins, like it'd be horizontally and vertically. But overall, I didn't really like the way it looked or the way it was designed, so I changed it to have just 3 of them. And I also changed the design before I had it as they looked like boat rudders, but now I found a 3D model of a shark fin, and I like the way this looked a lot better. So I changed it up a little bit and just attached a little servo horn on the bottom of it, so it attaches straight into the servo and should be good. The servos here, you might be asking, why am I leaving them on the outside? Because they're gonna get water damage. Most RC servos already have some type of waterproofing, but I'm gonna waterproof it even more so that it doesn't get damaged. And then the brushless motors also just sit right in that little hole. That design haven't changed, and that's all I've changed recently. First step is to waterproof the servos. Okay, so here, instead of using a water sealant, I decided to just use a soldering iron so I could just melt the plastic at the motor seams so that no water could get in. And this was pretty quick and easy, so it only took around like 1 minute, 2 minutes just to melt all the plastic around it. And then right afterwards I could just start filling it up with oil, and it was a lot faster than using like a spray water sealant, because then you have to like let it dry and all that. Plus this is just cheaper and easier. Okay, so now to actually waterproof the motor so no water gets in and short circuits the motor controller, all you're gonna do is just get some mineral oil and a syringe and just start filling up the inside of the servo with the mineral oil. So the reason why this works is because mineral oil is non-conductive, so it's just not gonna short out, and also helps so that instead of water coming in, if it comes in, it's not gonna hit it, it's just gonna hit the oil. And yeah, so it just helps keeps the water out, and overall it works underwater. So now I'm about to test this out right after I finish filling this up with oil. Alright, so I finished printing and I attached the servos onto it, and I also attached the fins to it, and this is what it's looking like. And I honestly really like how this looks compared to the last one. This one looks a lot more cleaner, a lot better, and the way I attach the servos are also a lot better. Okay, so now I'm about to actually test it, and once I connect the Arduino to the power plug, the motor should start moving. And then it's not fully submerged yet, but once I fully submerge it, you could see that it moves underwater as well. Okay, so I wrote some code for the servos to test. 2 of the fins are working right now. This fin, the connectors for the servo came off, so I just have to wait for my solder to arrive coming tomorrow so I could test it. So we're just gonna be testing this fin and this fin to see if it works. It should just spin 180 degrees back and forth a couple times with this. Yep, so it's working. Now I gotta work on the battery system. Series versus parallel in wiring. This is a battery, specifically an 11.1 volt 2200 milliamp hour battery. Now we have 2 batteries, and if I wire them in parallel, it's going to come out to be 11.1 volts and 4400 milliamp hours. Now you may ask me, what are the pros and cons of wiring it in parallel? The first pro is that it has an extended runtime, meaning it has the capacity of both of the batteries, which equates to 4400 milliamp hours, and basically it just doubles my submarine operational time. Keeping the voltage at 11.1 volts just overall matches the requirements of my components. Wiring it in parallel generates less heat than wiring it in series, so it just enhances the longevity of my batteries and all my electronic components. Since it's not that high of a voltage, I don't have to use any buck converters to connect it to any of the components, other than just connecting it to the servo and the ESP32. and it's just a lot safer overall. And here's the cons. It weighs more, it's weird to wire, it can charge unevenly, it could also overheat, and the voltage doesn't increase at all. Now we're going to do if I wired it in series. Okay, so now we have 22.2 volts and 2200 milliamp hours. So the voltage doubles and the capacity stays the same. So here are the pros and cons. So we got increased voltage output, improved system efficiency, simplified wiring and charging, enhanced design flexibility, and it just costs less. Okay, so here are the cons. Limited current capacity, dependency on individual batteries, imbalance issues, complex charging requirements, and voltage limitation. So here are the list of components. We have 2 batteries, 3 servos, 2 DC motors, 2 brushless motors, an ESP32, and also a ESP32 cam, and if we need it, I'm also going to use 2 buck converters. And after thinking about it and inputting my specs into ChatGPT, I decided to just go with parallel. Now all I gotta do is just design a battery pack. It's a very simple design. It's just a box with screw holders on the side and also a logo in the front. So basically all it does is just holds the batteries inside, so the batteries just slap into there and the wires come out from the top right over here. Alright guys, so now I'm going to show you guys how I built my battery pack. So the first thing I did was took some measurements of these 2 batteries that I have, and then I put it into the 3D printing software and designed a little holding case for it. So they really just sit in like... Okay, so now you got your battery pack, and then the next step after I 3D printed this was I started working on a 3-way splitter. So in this 3-way splitter, it has 2 Dean's connectors, so they just connect onto the battery like that. And then I connected 2 mini buck converters, and I wired them, connected to the splitter that I made for these Dean connectors, so that I wired them in parallel. So the positive is going to the positive, and the negative is going to the negative. And I also put one of the adapters so that I could attach this onto the brushless motor ESCs. So the reason why I got these mini buck converters is so that I could adjust the amount of voltage going into my components. So since it's 3-way, one of the buck converters goes into the ESP32, the other buck converter goes into the servos. So because the ESP32 runs in about 6 volts, and the servos, so for them to run good, they run about around 8 volts. So then this just connects straight into the brushless motor ESC because it's just sending out 11 volts. And then all you do once you wire them and secure all the wiring, so I just used a bunch of electrical tape, I soldered it all together, and I used heat shrink tubes. I would also suggest, if you're doing something like this, to put some heat shrink tubes around the mini buck converters. That's what I did right here. I just made a little hole on the side so I could use a little screwdriver to adjust the voltage. So once you connect them to the batteries like so, if they don't explode, that means it's good. So the way I'm going to test this out is I'm going to grab my Arduino. You guys see it's not turned on right now. Now all you gotta do is just focus on this light, and once I adjust the buck converter so that it allows some voltage through, the light will turn on. So you guys see it turns on, and when I just unscrew it. So that's basically how this works. And now since I know it works well, that means I wired it well, so nothing will explode. So yeah. So I decided to redo my ballast system. The reason I'm redoing my ballast system is because it's too big, and I want to keep one in the front and one in the back. And I had a rack and pinion system, and it was just way too big and way too complicated. So instead, I'm gonna turn the DC motors into water pumps. It's pretty easy. I just found a design online, changed it up a bit so that it could fit the motor that I'm using and fit how I wanted it to work. So I printed it out, and the way it's gonna work is I'm gonna cut 2 pistons to 30 milliliters, and then connect the pistons together through the tip, and then connect the 2 from the water pump to the outside, and then the other side of the water pump, I'm gonna connect that into the syringes. So once the syringes fill up with water on both the front and the back, the submarine should sink. Guys, I'm gonna show you guys how to build this water pump. So for me, I built 2 water pumps, but I'm gonna show you guys how to make one single one. So you need 1 motor holder, 1 fan, and 2 connector parts. Then after that, you're gonna need the electronics, like the motor. That's all you need for electronics, and you need a couple screws. So the way you're gonna put this together is you're gonna get the motor first, and you're gonna get the motor holder, slide it into the top, clip it in, and once it's at the top, you should be able to free spin this with your hand. If it's a little too tight, I'll suggest using like a heat source. I use my heat gun to loosen the hole a bit and move the axle around here so that I make sure that the axle has free axle spin. Next, you're gonna put the little fan on top. The best way to tell if the motor is spinning is you can check in the holes. If you see the axle spinning, you should be good. Put that in there. Next, you're gonna grab the top part and put it there. You're gonna start. You're gonna grab your screwdriver or rotary tool. So for me, I'm using a drill. So you're just gonna. And you're just gonna screw in every side. This is the first iteration of the water pump I made. So we're gonna test this out right now. So this is with the battery pack that, as you guys know, I've made in the past. So we're just gonna connect. It's gonna start running automatically. And once I dip it in there, see it's working. So for my next iteration, the things I'm gonna change right now, I'm about to 3D print it. So I'm gonna see if I can get a bigger gear, because if right now the gear is pretty small, so the amount of water that's coming in and coming out. So it's just a fan. This is basically just a fan. So once it runs, you can feel the air getting pushed out right here. So it's just redirecting the water like it was if it was an actual fan. Okay, so now I'm gonna build the ballast part itself. All right, so now I have to cut this syringe to the 30 4/5 mark, so about right here. So we're gonna cut that right now in 2 syringes. Alright, now we got both of the syringes roughly around the same length. So now what we're gonna do is we're gonna connect them through these parts right here. And then we're gonna connect the tube to them. Okay, so here was my poor attempt of melting the 2 tubes together, and it didn't end up working, so I ended up doing something else. But while I was recording, my phone ended up dying. But yeah, here was my poor attempt of trying to connect everything together, and it just wasn't going well. Okay, so my phone did die, but after wiring everything together, because that was a really good idea trying to bend it inside the other one, it actually kind of works. I'm going to show a video of me testing it out right now. Alright, then another update. I have to cut off the bottom of the stick that goes inside the syringe. Cut it off, welded it to the top, and then cut the other one, but left a little bit off the top, so if I need to pull it out with some tweezers I could. And so in total this should fill up around, give or take 50, 60 around there, and it needs around 90 milliliters for it to sink, so 2 of these should work fine. Alright, just like that. Now both of the things are full. So yeah.
Thanks for watching, and don't forget to like and subscribe.